Similar to how the nervous system forms one of the basic functional building blocks of our human body, so computer networks are at the very core of the interconnected, seamless world that we all know today. So hence it's a paramount importance to dedicate our efforts and focus on building and maintaining the security posture of our networks. Protecting our networks from an internal and external threats is one of the most important aspects of any information security program for an organization. In this chapter, we will be looking at the core concepts that will form our building blocks for a comprehensively secure network architecture, besides a few best practices and guidelines. And also for now, there's no technical requirements for this section of our course. For an effective network security apparatus to be in place, it is important to understand the central concepts associated with it and the implied technologies and processes around it that make it robust and resilient to cyber attacks. Today, some of the common challenges that security professionals face is the lack of clear distinction between the devices in their infrastructure and the data that they hold or process. This is further complicated when the visibility is blurred by not having a demarcation of the various network boundaries. So today we have evolved networks with components such as Internet of Things, Industrial Internet of Things, and cloud computing, which have further added to the network's complexity. Network security in itself touches upon various attributes of security controls that a security professional should take into account, such as security gateways, SSL inspection, threat prevention engines, policy enforcement, cloud security solutions, threat detection and insights, attack analysis, WRT frameworks, and so on. Therefore, it is important as a network security professional to not only have a clear visibility of your network, but also understand the effectiveness of your security products and solutions. The following subsections will help us get familiar with the key terms and components of network security. One of the most fundamental security principles that a lot of organizations miss is reducing or restricting the attack surface. This includes changing the default configurations and the lack of system hardening. Some of the ways in which system hardening can be implemented include disabling the default services, restricting default permissions that start up with the power on, default usernames and passwords, open ports, and so on. Concerning passwords and credentials, a policy must be developed that enforces the usage of complex passwords with more than an 8-character limit, with a mandated usage of numeric values, capital letters, and special characters. A password change policy must also be in place. Network segmentation. Network segmentation refers to segregating a network into subnetworks with the aim of improving performance and security, so a reduced attack surface and grouping systems with a similar security needs. This can be achieved by implementing firewalls, a virtual local area network, LAN, and software-defined networking, SDN, to name a few. Proper network segmentation will allow the organization to segregate low-priority and low-trust network areas from the rest of the infrastructure or critical network segments, thus preventing widespread impact on the event of a cyber attack. This also helps with utilizing security monitoring platforms and access controls for the most business circular segments of the organization. Network choke points. One of the major differentiating aspects between a fragile and resilient cybersecurity program is the strategy and approach toward building a comprehensive foundation. This foundation can be built only by having a clear visualization of the logical and technological layout of the environment. For example, identifying and adequately monitoring bottlenecks and choke points can often help us discover larger and deeper problems in the network's foundation. In military terms, a choke point is a location on land or sea, a valley or a strait, where the military is forced to pass through a narrow column, which makes it easier for an opposing force to take them out with ease. Technically, this is a shooting a fish in a barrel kind of situation. In networking terms, A similar situation is faced when the data flow of a network is restricted due to bandwidth or application constraints. From a network security standpoint, common examples include implementing a firewall for an internet-facing site or a load balancer that reroutes traffic based on a bandwidth consumption. In the case of distributed denial of service (DDoS) or denial of service (DOS) attack, this can add to cyber resiliency. So today we can build such scalable and highly available load balancers over the cloud by using services such as Google Cloud. Defense in depth. This is an implementation approach where multiple layers of security or defensive controls throughout the environment or landscape have redundancy in case of security incident. This is also known as the castle approach. So the reason why this approach is important is that it takes the weight of a single cybersecurity defensive control and supplements or complements the security strategy by having a multiple independent controls in place at different layers. Originally, this was a military strategy, also known as deep-in defense, that sought to hinder the movement of enemy forces. The focus is not on stopping them entirely via frontal assault, but by buying the time and slowing down the attack's progression. This is an effective measure as it often results in the attacker losing momentum over a period of time due to no or less progress. This vital time can be used to mount an attack on the assault forces or reinforce the defenses of the defending team. There's an English phrase that says a chain is no stronger than its weakest link, which means that a group is only as strong as its weakest link. In networking terms, this holds to the core. As discussed and explored in previous lectures, you as a new network security expert need to identify and account for a single point of failure and implement a highly dependable process that will be put in place to mitigate such instances. We should also ensure that the appropriate controls are implemented around such suspectable resources of the network as per their risk profile. Continuous monitoring and improvement. Proactive network scanning should be implemented to hunt for unauthorized devices in the network and to monitor for suspicious activity in the network. This would ultimately lead to the requirement of a well-defined incident response mechanism. Being a critical operational function, NOC also needs to aim for continuous improvement concerning processes, approaches, and the turnaround time to showcase business outcomes and value creation. The major focus here is to verify whether all the deployments are accurate and operate as expected. The idea is to evaluate the actual versus expected levels of service delivery and performance. Now that we are familiar with the various network security concepts and their key components, next we will take a look at the systematic approach that organizations should follow for a comprehensive network security architecture. Due diligence and cyber resilience. An organization must have a cybersecurity program that aims to annually review the cyber resilience of the organization's network. This is important from various aspects. First, this ensures that the operations team is ensuring due care and due diligence across the network. Second, this gives the leadership and operations team visibility into how the network has evolved over this period and what new changes have been made. So how they impact the network topology and how these change the threat landscape from the organizations in terms of new threats and vulnerability susceptibility that may stem from these changes. This also helps in mapping the relevancy of the security controls and level of compliance. Understanding network maps. Network maps in cybersecurity are network topology graphs that describe the physical and/or logical relationship and configuration between links, which is communication connections, and nodes, which is devices in the network. To better understand the concept, consider road maps or maps in Atlas. These describe physical locations, geographic features, political borders, and a natural landscape. Information about roads, which is these are the links. So these their name, orientation, length, and intersections between other roads. And these can be used to navigate between different locations, which is nodes. Now, let's consider the following hypothetical scenario. Imagine you live in a world where roads and buildings spontaneously appear or vanish in the blink of an eye. GPS exists, and you have the coordinates of where you are and where you want to go, but you must try to get there by following a bewildering network of constantly changing roads. Fortunately, navigation officials, which is routers, are placed at every crossroads to help travelers like you find their way. These routers are constantly calling their neighboring routers to learn what routes and locations are open so they can update their routing table and kept on a clipboard. You must stop at every intersection and ask the router for directions to the next corner by showing them your travel card, which has your intended destination coded in the GPS coordinates. The router checks their clipboard for currently open routes while making some calculations, quickly points you in a direction, stamps your travel card with the router's address, hole punches your travel card to track the number of routes you have checked in within your journey, and sends you off to the next router. You repeat this process until you reach your destination. Now imagine these world's cartographers, who would have likely given up on producing accurate maps, unable to keep up with the ever-changing network. These map makers would have to be satisfied with labeling key landmarks and points of interest with generic names and drawing fuzzy lines between these points to indicate that the path of some sort of exists between them. This hypothetical situation is in fact what exists in cyberspace, and it's why network maps are not as accurate and their maintenance is not as prioritized as it should be. The lack of high-quality, comprehensive network maps is a recognized challenge for cybersecurity organizations. If an organization has a map at all, it's typically provided to the Security Operations Center (SOC) to illustrate where sensors or security devices are in the flow of data and to better understand packet captures, firewall rules, alerts, and system logs. However, it's probably also abstract, describing only basic features such as boundaries for the internet, perimeter network, and intranet. The general location of edge routers or firewalls and unspecified network boundaries and conceptual arrangements indicated by Claude bubbles. An example of underdeveloped yet common network map available to cybersecurity and IT professionals you can see here on the screen. Network security best practices and guidelines. Network security does not just end when we implement security products or processes. A network is like a living and breathing organism that evolves with time, but sometimes breaks down and needs maintenance. Apart from security uses, there are many common uses that can occur, so including network connectivity uses, power outages, network crashes, and black holes in routing. Typically, a Security Operations Center (SOC) is something that is the center of security monitoring and operations, but at the same time, a Network Operations Center can play a very important role in a network resilience and optimal performance. In this section, we will take a look at some of the key attributes of the Network Operations Center. A Network Operations Center is a central entity for organization's network monitoring endeavor. This encompasses technology and processes essential to actively managing and responding to networking-related uses. A typical network operations center consists of engineers and analysts monitoring the network and ensuring smooth operation and ensuring network infrastructure uptime. This includes, but is not limited to, network device, server, application, and endpoint monitoring, hardware and software installation concerning network devices, and network analysis, and which is discovering and assessments. Network operations centers often encounter complex networking issues that might need troubleshooting and collaboration between different IT teams to investigate and resolve the issue. To increase the overall effectiveness of a network operations center, organizations focus on a few areas, as discussed in next subsections. Proper incident management. This will include identifying an incident, investigating the root cause, resolving the incident, and preventing its recurrence to avoid business disruption. For a more evolved look at the best practices for incident management, and the organization should review and analyze their adherence for the ITIL incident management framework. This includes prioritizing incidents based on their impact, accurately reflecting on the current status and documentation of all artifacts, implementing a streamlined process to ensure that the effective handling of incidents that's in line with the organization's policy, automating elementary manual iterative tasks and escalations, implementing an effective communication mechanism for sharing real-time updates with the required stakeholders, integrating third-party applications such as ticketing systems, monitoring dashboards, a knowledge base, threat intelligence, and so on to make the analysts more powered, establishing key performance indicators, and driving continuous improvement by reporting on them. This helps the organization continuously improve and innovative on its performance metrics and key deliverables such as higher performance quality, lower cost to serve them, and their mean time to resolve. An incident response team should consist of a hierarchical team structure, where each level is accountable and responsible for certain activities, as you can see here. Tier 1 analysts. Tier 1 analysts acts as the first point of contact in the incident response process. They are responsible for recording, classification, and first-line investigation. Tier 2 analysts. Tier 2 analysts act as an escalation point for Tier 1. Also acts as a SME for deeper investigation and creation of knowledge articles. They are also required to escalate major incidents to Tier 3. Tier 3 analysts. Tier 3 analysts act as an escalation point for Tier 2 and is responsible for restoring an impacted service. They escalate unresolved incidents at a relevant vendor or team for resolution. They also act as a liaison between internal and vendor teams. Incident coordinator. Incident coordinator acts as the administrative authority, ensuring that the process is being followed and the quality is maintained. They are responsible for assigning an incident within a group, maintaining communication with the incident manager, and providing trend analysis for iterative incidents. Incident manager. Incident manager manages the entire process until normal service is restored. They are primarily responsible for planning and coordinating activities such as monitoring, resolution, and reporting. They act as a point for major escalations, monitor the workload and SLA adherence, conduct incident reviews, provide guidance to the team, and ensure continuous improvement and process excellence. In some organizations, there are other roles such as Incident Assignment Group Manager and Incident Process Owner, who is accountable for designing, maintaining, and improving the process to ensure the efficiency and effectiveness of the service's delivery. Assessing network security effectiveness. Network security assessment addresses the broader aspects of the security functionality of a network. This should involve exploring the network infrastructure to identify the different components present in the environment and cataloging them. Ideally, this should be followed by assessing the technical architecture, technological configurations, and vulnerabilities and threats that might have been identified as a part of the first step. Following this, we should focus on the ability to exploit these identified threats to validate their impact and risk factor, which may be based on a qualitative or quantitative approach. This helps us in driving accurate prioritization and business context, as well as the corresponding remediation plan. Some key concepts that we will be covering in this course as a part of the network security will form the fundamental and foundational capabilities that enable us to check the right boxes and derive an appropriate value for each. In this section, we will investigate the major domains that can help us assess the maturity of the network. Static analysis. This focuses on auditing application code, network and server configuration, and providing an architectural review of the network. This exhaustive and is work and time intensive, but derives a lot of valuable insights into the inner workings of the various components and configuration errors and vulnerabilities that might persist in the environment as they are conducted at runtime. Therefore, we need to break this into small, actionable steps such as design review, configuration review, and static code analysis. Dynamic analysis. Dynamic analysis focuses on the threat actor's perspective, who aims to exploit the services and threat vectors that can result in the loss of confidentiality, integrity, and availability, and this can be inclusive of network infrastructure testing, web application and services testing, and dynamic code analysis. Also remember that static analysis is more focused on preventive checking, whereas the dynamic analysis focuses on resolving existing vulnerabilities and flaws. Static analysis is cost efficient and takes less time compared to dynamic analysis. This is because static analysis is generally done before deployment and is less extensive due to the efforts that's involved. Configuration review. Configuration review this focuses on the auditing network components at a low level, such as firewalls, routers, switches, storage, and virtualization infrastructure, server and appliance operating system configuration, and application configurations. You can leverage configuration reviews to perform gap analysis and document possible flaws in the configuration and mitigate the identified ones. You can also prioritize the recommended actions based on their severity and impact. The low-hanging ones should be addressed quickly. Design review. This concentrates on implementing security controls and evaluating their effectiveness and applicability. For example, ISO ES 15408 12208 is an industry-recognized certification that accounts for general concepts and principles of IT security evaluation. It captures a variety of operations. The functional and assurance components are given in ISO ES 15408-2 and ISO ES 15408-3 and can be tailored for the relevant operations. Network infrastructure testing. This segregates network testing in the form of vulnerability assessment and the penetration testing. There is a wide range of tools and platforms that can be utilized for the same that will scan the network and infrastructure for potential vulnerabilities and provide a base for manual or automatic testing of the explored vulnerabilities or flaws. Web application testing. Web application testing involves assessing an application from various approaches to test for weaknesses in the source code, application and business logic, authenticated and unauthenticated application processing, and configuring and implementing flaws. OWASP is a brilliant resource for digging deeper into application security practice. So far, we have explored The various major aspects that should form the basic building blocks of a good network security architecture. Next, we will take a look at some technical management aspects. Threat modeling. This is a structured approach toward network security that assesses the potential threat landscape concerning the point of view of an attacker. This takes into consideration the attacker's motives, threat profile, their capability and skill, key assets of interest, and the most likely attack vector to be used, among other attributes, to understand which threats are most likely to materialize and how they will unfold in the environment. The idea behind this is to understand the environment better by reviewing all the components and processes. Today, most threat modeling methodologies focus on one of the following approaches: asset-centric, attacker-centric, and software-centric. The following diagram shows what risk inherently means. Risk is when we have an asset that is vulnerable to a certain flaw or loophole, and we have a threat vector that can exploit the vulnerability. Ultimately, this impacts the asset and confidentiality, integrity, and availability. In this diagram, A is asset, T is threat, V is vulnerability, and R is risk. There's steps to explain the threat modeling process. First, the scope of the analysis is defined and each component of the application and its infrastructure is documented. Second, this is followed by developing a data flow diagram that shows how each of these components interacts. This helps us assess the control mechanism. Privileges are verified for the data movement. Third, then potential threats are mapped to these components and their risk impact is quantified. Fourth, and finally, various security mitigation steps are evaluated that might already be in place to mitigate such threats. Here we document the requirements for additional security controls if applicable. On the flip side, an attacker might conduct an exercise similar to the following threat modeling. They would start by evaluating all possible entry points into the network, application, or infrastructure. Second, the next step will be focused on the dataset or assets that will be accessible to them via these access points and then evaluate the value or possibility of using these as a pivot point. Third, post this, the attacker crafts the exploit and executes it. Now that we have a basic understanding of the threats that we may face, it's important to have standardized frameworks that can be referred by the professionals to assess the nature of these threats and the impact they may have. Assessing the nature of threats. You, as a security professional, can use various industrialized risk frameworks and methodologies to assess and quantify the nature of threats. Some of the prominent ones will be discussed in next lectures. STRIDE. STRIDE is a security framework that classifies security threats into 6 categories. Spoofing of user identity, tampering, repudiation, information disclosure, denial of service, elevation of privilege. This was developed by Microsoft to verify security concepts such as authenticity, integrity, non-repeatability, confidentiality, availability, and authorization. PASTA, Process for Attack Simulation and Threat Analysis. PASTA. PASTA is a risk-centric approach focused on identifying potential threat patterns. This is integrated application threat analysis that focuses on an attacker-centric view that security analysts can leverage to develop an asset-centric defense strategy. It has 7 stages that build up to the impact of a threat. These stages are definition of the objectives for the treatment of risks, definition of technical scope, application decomposition and assertion, threat analysis, weakness and vulnerability analysis, attack modeling and simulation, risk analysis and management. Next, we will take a look at the TRIKE framework and see how it's used for security auditing for risk management. TRIKE is a framework for security auditing from a risk management outlook perspective. The process starts with defining the requirement model that the threat models are based on. The requirement model outlines the acceptable level of risk which is associated with each asset class. The matrix is further broken down into actions such as creating, reading, updating, and deleting, along with associated privileges such as allowed, restricted, and conditional. By following this, possible threats are specified, mapped alongside the risk value, which is based on a 5-point scale for each action based on its probability. VAST: Visual, Agile, and Simple Threat Modeling. VAST is an agile software development methodology with a focus on scaling the process across infrastructure and SDLC. VAST aims to provide actionable outputs for various stakeholders, and the scalability and usability is a key factor for its adaptability in larger organizations. This diagram illustrates a VAST model. VAST utilizes two threat models: the application threat model and operational threat model. The application threat model uses process flow diagrams to represent the architectural viewpoint, whereas the operational threat model uses data flow diagrams to represent the attacker's viewpoint. OCTAV: Operationally Critical Threat, Asset, and Vulnerability Evaluation. OCTAV is a security framework that utilized for assessing risk levels and planning countermeasures against them. The focus is to reduce risk exposure to potential threats and determine the likelihood of an attack and its impact. It has three broad stages, and these are: building asset-based threat profiles, classification of infrastructure vulnerabilities, creation of an overall security strategy and activity plan for the successive exercises. It has two known formats: OCTAV S, which is simplified format suitable for smaller organizations, and OCTAV Allegro, which is a more comprehensive format suitable for large organizations. In this section, we have taken a look at the foundational network security concepts and components that form the strong base that's required for a secure network implementation. After this, we took a step-by-step dive into various phases of building network security, which are planning and analysis, designing, building, testing, and deployment. In the second half of the section, we have looked at an optimal NOC setup and its various attributes, such as incident management, monitoring, escalation, and reporting. Lastly, we dug into network security assessments and discussed threat modeling. By completing this section, you now understand that network security is a vast domain that requires a bottom-up approach if you wish to fully understand the minute mechanisms that make it tick. As a security professional, you must have a good exposure to the fundamentals of network and the models and frameworks explained in this section, while at the same time be able to identify and remediate deep-seated technical issues. I highly recommend doing a foundational assessment of the network configuration and reviewing policies and procedures in place in order to incorporate security from the inside out. My name is Typhoon, and in this lecture you will learn and understand the lab overview and its technologies. You will learn how to set up hypervisor and virtually isolated networks. You will also set up and work with Kali Linux. You will also learn how to install Metasploitable 2 and Metasploitable 3. The first is target as a target and Metasploitable 3 as a vagrant. So you will also learn the vulnerable web application systems. So let's get started. As a feature ethical hacker or penetration tester, it's quite important when testing exploits, payloads, or practicing your hacking skills that you do not disrupt or cause any sort of harm or damage to another person's system or network infrastructure, such as that of your organization. While there are many tutorials, videos, and training programs you can read, watch, and to gain knowledge, working in the field of penetration testing means focuses on continuously enhancing your skills. Many people can speak about hacking and explain the methodology quite clearly, but don't know how to perform an attack. So when learning about penetration testing, it's very important to understand the theory and how to use your skills to apply them to a real-world cyber attack. In this section of our auxiliary course, you will learn how to design and create your penetration testing lab environment and on your existing computer using virtualization technologies. You will learn how to create a virtual isolated network to ensure you do not accidentally attack systems that you do not own. So then you will learn how to set up Kali Linux as an attacker system and vulnerable clients and servers as your targets. So practicing your hacking skills on systems and networks that you do not own is an intrusive and illegal because it can cause harm and damage to those systems. Building a virtual penetration testing lab allows you to create an environment that is safe for you to hone your skills in. Scale the environment to add new vulnerable systems and even remove older legacy systems that you may no longer need. And even create virtual networks to pivot your attacks from one network to another. The concept of creating your very own virtualized penetration testing lab allows you to maximize resources on your existing computer without the need to purchase an online lab time from various service providers or even buy an additional computers and services. So you don't need to buy these kind of technologies. You can just use the virtualization technologies. So overall, you will be saving a lot of money as opposed to buying physical computers and networking equipment such as switches and routers. So as a cybersecurity trainer and professional, I have noticed that many people who are beginning their journeys within the field of information technology usually think that a physical lab infrastructure is needed based on their field of study. To some extent, this is true. But as a technology advance, many downsides are associated with building a physical lab to practice your skills. There are three main downsides and disadvantages of this. The physical space is required to store many servers and networking appliances that are needed. There are also power consumption per device will result in overall high rate of financial expenditure, and the cost of building or purchasing each physical device is high, whether it's a network appliance or a server or just a computer. So these are just some of the concerns many students and aspiring IT professionals experience. In many cases, a beginner usually has a single computer, such as a desktop or a laptop computer. So being able to use the virtualization technologies that have merged as a response to these downsides has opened a multitude of doors in the field of IT. So this has enabled many people and organizations to optimize and manage their hardware resources more efficiently. In the world of virtualization, a hypervisor is a special application that allows a user to virtualize the hardware resources on their systems so that they can be shared with another operating systems or an application. So this allows you to install more than one operating system on top of your existing computer's operating system. So imagine that you are running Microsoft Windows 10 as your main operating system, but you wish to run Linux at the same time on the same computer. You can achieve this by using hypervisor. So hence we are going to use virtualization to ensure we can build a cost-effective penetration testing lab environment. In this course, we're gonna need several applications and frameworks to install our virtual penetration testing lab. So firstly, we're gonna need the hypervisor. This hypervisor is required for creating virtual machines. We will be using the VMware player, but you can also use the Oracle VM virtual box. So we're gonna need internet access. This is required for downloading additional applications. Internet access will be provided to our attacker systems while ensuring all our systems remain virtually isolated. We will need a machine, a penetration testing machine. So the system will be attacker system, and we will be using Kali Linux. We will need vulnerable client systems. So this will be our target and victim systems for security testing. The vulnerable systems will include Metasploitable 2 and Metasploitable 3. Both Windows and Linux versions, of course. So through additional systems may be added as you progress through this course. We will also, lastly, we will need the vulnerable web applications. So these are the systems that contain vulnerable web applications to help you understand the security weaknesses in web applications. So this will be Open Web Application Security Project, OWASP, and the OWASP Broken Web Application, BWA. Furthermore, this diagram is our network penetration testing lab topology. Let's get started. And so I drew and created this topology to show you how our networking IP addresses is contained and how which virtual machine has the following IP addresses. Here we're gonna need the main virtual machine. So this is gonna be Kali Linux. Increase the font. So, and in this Kali Linux, this Kali Linux will connect to our Windows machine. Windows machine, or like just a computer here. This is our main machine here. In this case, it's gonna be my laptop. Main machine, and here and between this here, actually, we're gonna need virtual machine. This is our VMware. We're gonna have installed VMware here, and in this VMware player, virtual machine player, we're gonna use Kali Linux. We will also need the Red Team Lab. This is gonna be our Red Team Lab, and we will need okay, this is a Kali Linux. We will also need the Metasploitable, and this is our Metasploitable systems. And this main machine is gonna connect to internet, but they're gonna be isolated, so don't worry about that. And here these are gonna be connect to internet and internet. So this is our basic diagram for creating our virtual machines. Now that you have an idea of the lab topology, as well as the systems and technologies which we are going to be working with throughout this course, let's get started by setting up a hypervisor and virtual networks in next lecture. VMware Workstation Player, formerly known as VMware Player, is a free for personal use tool, and you can download this tool from the official website VMware download. Here, just a basic search. You're not gonna download the Pro here. We're just gonna download free version of it, which is actually does the job pretty much the same as the open source applications, but VMware is actually faster than the Oracle VM VirtualBox. That's why we're gonna use this here, and it has the VMware player has an like more features than the VirtualBox, so that's another reason we are gonna download and install it. But you can also download the VirtualBox from its website, Oracle VM VirtualBox. It's a free and open source tool. As you can see, we are getting some error here. Okay, you can download this from, yeah, that's not the website. VirtualBox download. We're having trouble with connecting VirtualBox website, so we're gonna download it from the file hippo. Log, download the latest version. As you can see here, we downloaded the VirtualBox installer, and we're not gonna install the installer. So let's actually .org site try this. Instead of using file hippo, we can also use the SourceForge. Okay, as you can see, we have a Softpedia. Yes, we can download from this. This is actually trusted website. And we have our Is it fixed yet? Yes. So let's get started with downloading the virtual VMware and then continue with VirtualBox. Here, click on the download. And as you can see, VMware Workstation Player. You can install this VMware Workstation Player in Linux and Windows. As you can see, the latest version of VMware has only the 64-bit versions. So if you have the 32-bit desktop or laptop device, so you need to install the 32-bit. So since you need to install the older versions of it. So download, click on download now. I'm using Windows and click on download now. And as you can see, it's for today, it's, and last version of it is 577 megabytes. Just let's see. No, we are having trouble for reaching VirtualBox website. The reason of it, here we are installing VMware player now. And as you can see, the VirtualBox website is loaded as well. The VirtualBox actually is open source, and that's why it has like you can install on macOS, Windows, Linux, Solaris, and other operating systems. You can also install ARM64 and click on Windows hosts. And as you can see here, the VirtualBox has a smaller size compared to VMware Player. And yeah, it's two of them is installing, and let's wait and complete the installation now. Okay, so our VirtualBox is installed, and let's open this and see the installation process of VirtualBox. Since we're not going to use the VirtualBox anywhere, so I'm gonna just show how to install the VirtualBox if you want to use it. Click on next, and as you can see, there's an you need to open the and select the modules to install. So just leave it at as the default. Click and click yes. So as you can see, missing dependencies. Installing worker is Python bindings requires Python core package. So let's install whatever. And as you can see, it's installing now. And let's also try installing VMware player. So I'm actually on the virtual machine now. This operating system itself is virtual machine, as you can see here, but I don't think VMware is gonna install on the virtual machine. But let's check here. Yeah, finish. As you can see, the VirtualBox is installed without a problem. And let's open the VirtualBox here. As you can see, with this you can create add the virtual machine files. If you have downloaded one from the Kali Linux official website, you can create a new from this. And here let's install the VMware. You can also install the Enchant keyboard driver, but no, here do not join and do not check the product updates on the startup. Next, yes, add the icons to desktop. Yes, install. So let's go to Oracle VirtualBox here. So with this new keyword, you can enter the virtual machine name, folder that you're gonna save the virtual machine files in it, and the ISO image, and the operating system types after selecting the ISO image. So the good thing about the VMware is whatever the ISO image you're selecting, the VMware will choose system automatically for you. So I think the VMware is better virtual machine application than VirtualBox, but you can select your choice and use whichever is good for you. And as you can see here, use VMware Workstation Player for free for non-commercial use. Since we're not going to use the VMware for non-commercial use, we're going to click on that and click on continue and click on finish. And as you can see here, our Workstation Player 17, the last version of VMware, is opened. With this, actually in next lecture we're going to install the needed metasploitable Kali Linux on it. So I'm not going to show it in this lecture, but I wanted to show it how the VirtualBox interfaces looks and how to set that. So in next lecture we're gonna install the operating system and virtual machines in VMware. So I'm waiting you in next lecture. The next step in order to install Kali Linux on a VMware is to go to kali.org website and download the VMX file. So as you can see, we have a download button here. Click on that. We can also download the installer images, and we can also download the virtual image machines here. So as you can see, in installer images, we have advantages that we can direct access to hardware, we can customize Kali kernel, and no overhead. But in the virtual machines, we have snapshot functionaries, isolated environment, customized Kali kernel, but we cannot direct access to hardware because we are using the virtual machine and we have higher system requirements, and it's not that high system requirements here. And we can also install the Kali on mobile, cloud, WSL, live boot, which we're gonna create a live bootable system in Kali Linux. And you can also use the containers for Docker or LXT. We can also install the RM based devices. So in mobile, we can also we will also do the mobile penetration testing platform for Android based devices. But in this lecture we're gonna install the Kali Linux via the virtual machines here. And here, as you can see, we have 64-bit and 32-bit options select your, in order to know if your computer is 64-bit or 32-bit here. Just write this PC here. This PC you probably know, but there's a new BIOS here, so it's always good to learn. As you can see here, we have 64-bit operating system. So we're gonna download the 64-bit operating system, and you also need the 64-bit VMware in order to install 64-bit virtual operating systems. And as you can see here, we have 64-bit 2.6 gigabytes of file size, and that's the same for VirtualBox. But if we install it via the ISO file, and as you can see, we have 3.5 gigabytes of file size. So in this lecture, we're gonna install the virtual operating system as a Kali Linux. And as you can see, this is 7-zip format. Click on install, and you can also download a torrent. Let's go to docs, see here. And as you can see, the VMware itself is used as a Workstation Pro. And there's actually steps how to do it. You can also go to VirtualBox docs here, documents, and as you can see, there's also the following how to install. Actually, they are not how to install, they are just showing you. Yes, so we have already downloaded Kali Linux, and as you can see here, that's the last version. So when we open it, as you can see, we have several virtual VMware virtual disk files. So let's extract these files to desktop by dragging to desktop here, and as you can see, it's processed. We can also install the, actually let's open Oracle VMware VM VirtualBox. So if you are using the VirtualBox in order to open the downloaded operating system image, you just click on the import and select the file. It's actually pretty much the same to VMware, but they are actually use different platforms. But I prefer you to use VMware for just it's actually more compatible to systems. But you can also use VirtualBox here. Here it's 75%, 80. So it signs it's actually 2.5 gigabytes files, or let's see what. Actually, when you extract these files, it's like 13 gigabytes. Let's see how many, what size is it? Properties, yeah, it's 12.3 gigabytes. It's actually, as you can see here, the power of compressing files. So click on the, after like extracting your Kali Linux files to the folder from the zip file, click on the player, file, and open. And here click on the desktop, and as you can see here, we can select only one file, which is VMware Virtual Machine Configuration VMC, and click on double click or click just on open. Here, as you can see, we got the VMware. In this virtual machine, we can increase the RAM to 4 gigabytes, processors 2, hard disk. As you can see, by default, it has 80 gigabytes of hard disk, so it's actually enough for doing penetration testing. And we will also do the NAT user to use to share the host IP address. But later we're gonna edit these networks for our penetration testing lab. And you can also use these displays. Okay, here play virtual machine. Yes, as you can see here, this host does not support Intel VTX. Since this Windows itself is a virtual machine, as you can see here, I'm gonna open this in my main machine. Okay, so this is my main machine, and let's open the VMware here, and as you can see here, when we click on the Kali, take ownership. Okay, let's open it again. Here, open the Kali Linux. As you can see, we have already deleted it. Open this Kali. Okay, and as you can see here, our installed Kali Linux is finally opened. Hello, in this lecture we're gonna install and configure Metasploitable 2 as a target system. When building a penetration testing lab, it's important to include vulnerable systems that will act as our targets. So these systems contain intentional vulnerable services and applications so that we can practice and build our skills to understand how to discover and exploit vulnerabilities. A very popular vulnerable machine is known as Metasploitable 2. So this vulnerable machine contains a lot of vulnerabilities that can be exploited and is good for learning about penetration testing. So let's get started. Firstly, we're gonna install the Metasploitable 2 from the source forge. So firstly, go to https source forge. Actually, we can just Metasploitable 2 download, and here we're gonna go to Metasploitable 2 files, Metasploitable 2, and click on the source forge link and download the Metasploitable 2.0.0. This is almost 1 GB file, so I don't think it should take more time than 5 minutes, depending on your internet access, of course. So I have already downloaded it actually, so let's move it to here. As you can see, this is our Metasploitable 2 machine. So now let's here drag and drop and extract it from the zip file. So we can actually stop this, so we don't need it anymore here. So then open our virtual machine, and here click on the player, click on the file, and click on the new virtual machine here. So then create actually 1 minute. Yeah, as you can see, this is a VMware virtual disk machine. So where I will click on the I will install the operating system later and click on next, and here click on Linux, choose Linux here, and choose the other Linux kernel 64-bit here, and click on next. 8 GB is okay for Metasploitable or not. Actually, let's check. Yeah, 8 GB is okay for Metasploitable. We are not gonna create a new disk here, so I just need 0.2 GB. Here hard disk 200 MB, memory is okay, and click on finish. After that, click on edit. Actually, let's change this Linux 4. Kernel to here Metasploitable here, and after click on the hardware, click on add disk here, click on hard disk, next, and click on use an existing virtual disk, and browse and show the our VMware virtual disk image file, and click on finish. Click on keep existing format, okay, and play virtual machine. Since we are already installed the virtual machine Windows, so I'm gonna go to main machine now and see what happens next. here. Main here. This is our Metasploitable Linux. Go to drag and drop here, here. And let's look at an NVRAM here. Oops, we actually just create a new folder and drag and drop it here. Open our VMware. By the way, this is my main machine VMware. We got that error because we already installed the VMware inside it. So click on player, file, new virtual, and here we're gonna get the auxiliary desktop. Here, this is the disk we're gonna choose. Properties. Yes. Here. Desktop. SS. I will click on I will install operating system later. Linux. Linux for 64-bit. Next. Do not create any disk. And yes, so here edit virtual machine as again as always, and click on add hard disk, SCSI, use an existing virtual disk, and here show the Metasploitable VMD key here and keep its existing format. Click OK, and let's start our Metasploitable. Yes. So we need to actually delete our first disk that we created because no system installed in it. Remove. Okay. Yes. As you can see, the group loading and our Metasploitable is installed. So I'm gonna go to change the view to our Metasploitable disk, Windows capture exploitable, and here this is our Metasploitable system. As you can see here, the admin and password is right here, msfadmin, and here we log it into Metasploitable. To attack network protocols, you need to understand the basics of computer networking. The more you understand how common networks are built and function, the easier it will be applied to that knowledge to capturing, analyzing, and exploiting new protocols. Through this section, I will introduce the basic network concepts and that you will encounter every day when you're analyzing network protocols. I will also lay the groundwork for a way to think about the network protocols, making it easier to find previously unknown security issues during your analysis. So let's get started by the network architecture and protocols here. Network. So this is our topic here that you will learn about. So let's start by reviewing some basic networking terminology and asking the fundamental question: what is a network? So the network is a set of two or more computers connected together to share information, and it's common to refer to each connected device as a node here. As you can see here, workstation node, mainframe node, server node, and this is our network here. So so it's common to refer to each connected device as a node on the network to make the description applicable to a wide range of devices. Here you are seeing a very simple example of our nodes here. So this the diagram shows 3 nodes connected with a common network, and each node might have a different operating system or hardware, but as long as each node follows a set of rules or a network protocols, it can communicate with other nodes on the network. So to communicate correctly, all the nodes on a network must understand the same network protocols. Here, let's actually, I just here. So, and this is the functions and what the network protocols serves in our network here. So, the network protocols serves many functions, including one of these functions here. So, this is the maintaining state, session state. So, these protocols typically implement mechanisms to create new connections and terminate existing connections. Here we this protocol also does identifying nodes through addressing here. So data must be transmitted to correct node on a network. So some protocols implement an addressing mechanism to identify specific nodes or groups of nodes. And we are also going to control the flow, so controlling flow. So this is the amount of data transferred across a network is limited, of course. So the protocols can implement ways of managing data flow to increase throughput and reduce latency. And we are also going to be guaranteeing the order of transmitted data. So many networks do not guarantee that the order in which the data is sent will match the order in which it is received. And a protocol can reorder the data to ensure it's delivered into correct order. And we are also going to detecting and correcting errors here. So many networks are not 100% reliable, right? So data can become corrupted, and it's important to detect the corruption and ideally correct it. And here, lastly, formatting and encoding data. And the data isn't always in a format suitable for transmitting on a network, and the protocol can specify ways of encoding data, such as encoding English text into binary values. The Internet Protocol Suite. TCP/IP is the de facto protocol that modern networks use. Although you can think of the TCP/IP as a single protocol, it's actually a combination of 2 protocols: the Transmission Control Protocol TCP and the Internet Protocol IP. And these 2 protocols form part of the Internet Protocol Suite, IPS. So this is the Internet Protocol Suite and these diagrams. And I will explain all of these diagrams right now here. So, and this Internet Protocol Suite, this is the conceptual model of how network protocols send network traffic over the internet that breaks down network communication into 4 layer as shown in here. So application layer, transport layer, internet layer, link layer. And Ethernet PPP is link layer, IPv4, IPv6 is internet layer, TCP and UDP is transport layer. Actually, let me add comma here. TCP and UDP is transport layer, HTTP, SMTP, DNS is, and etc. is application layer. And these protocols are more, but this is just most used protocols in Internet Protocol Suite. And these are the external connections here. So the link layer directly connects to physical network, and also physical network connects directly to link layer here. So actually, let me get this here, and here. I will apply the same for user application, right? Here, whether it is a browser or just an online game, this is works like that. So now I will explain Internet Protocol Suite. So let's get started with the link layer, this link layer here. So this layer is the lowest level and describes the physical mechanisms used to transfer information between nodes on a local network. And well-known examples include the Ethernet, both wired and wireless, and the point-to-point protocol PPP. We also have the internet layer here. So this layer provides the mechanisms for addressing network nodes, and unlike in layer 1, the nodes doesn't have to be located on the local network. This level contains the IP. On modern networks, the actual protocol used could be either IP version 4 or IP version 6. And here we also have the transport layer. So this layer is responsible for connections between clients and servers, and sometimes ensuring the correct order of packets and providing service multiplexing. And service multiplexing allows a single node to support multiple different services by assigning a different number for each service, and this number is called the port. So the TCP and user datagram protocol operate on this layer. And we also have the application layer. So this layer contains network protocols such as the Hypertext Transport Protocol, HTTP, which transfers web page contents, and the Simple Mail Transport Protocol, SMTP, which transfers the email, and the Domain Name System Protocol, DNS here, which converts a name to a node on the network. Through this course, we will focus primarily on this layer. Actually, in this section, we will focus primarily on this layer, but in all of our course, we will learn all of these layers and protocols. So see you in next lecture. Each layer here interacts only with the layer above and below it, but there must be some external interaction with the stacks here. So here I draw some diagrams that will show you two external connections, and the link layer interacts with the physical network connections transmitting the data in a physical medium, so such as pulses of electricity or light. And the application layer interacts with the other application, and an application is a collection of related functionality that provides a service to a user. And in this figure, you are seeing an example of an application that processes an email. And the service provided by the email application is sending and receiving of messages over a network. And here, typically, applications contains these components, which is the network communication. This component communicates over the network and processes incoming and outgoing data. For a email application, the network communication is most likely a standard protocol such as SMTP, POP3, IMAP, or others. And we also have the content parsers here. Oops, actually we have here content parsers. So data transferred over a network usually contains content that must be extracted and processed. So content might include textual data such as the body of an email, or it might be pictures or video. And we also have the user interface, and this is the user interface that user interacts to it. So the UI allows the user to view received emails and to create new emails for transmission. In email application, the UI might display emails using the HTML in a web browser. And then I will also notify you that the user interacting with the UI doesn't have to be a human being. It could be another application that automates the sending and receiving of emails through a command line tool. The PDU, the protocol data unit, in each layer contains the payload data that is being transmitted, and it's a common to prefix a header which contains information required for the payload data to be transmitted, such as the addresses of the source and destination nodes on the network, to the payload data. So sometimes the protocol data unit, PDU, also has a footer here that is suffixed to the payload data and contains values needed to ensure correct transmission, such as error checking information. And here in this diagram, I created how PDUs are laid out in the IPS. Remembering from the previous lectures, IPS means Internet Protocol Suite. Here. So let's get started with the application layer here. So you can see here we have layer 4, we have application, station, internet layer, and the link layer. Now I will explain all of these layers and their payloads, headers one by one. So the TCP header contains a source and destination port number, which is here, source and destination port number here. And these port numbers allow a single node to have a multiple unique network connections, and port numbers for TCP and UDP range from 0 to 65,535 here. And the most port numbers are assigned as needed to new connections, but some numbers have been given a special assignment, such as the port 80 for HTTP. You can find the current list of assigned port numbers in the etc services file on the most Unix-like operating system, but you can also check in from the Wikipedia from internet. And a TCP payload and header are commonly called a segment, whereas a UDP payload and header are commonly called a datagram. The IP protocol uses a source and destination headers. The destination address allows the data to be sent to a specific node on the network, and the source address allows the receiver of the data to know which node sent the data and allows the receiver to reply to the sender. IPv4 uses 32-bit addresses, which you will typically see written as a 4 numbers separated by dots, such as this: 192.168, 192.168, here 10 and 1. So this is an example IP version for IP address. And IPv6, actually let me notify here, IP version 4. So, but the IPv6 here, IPv6 uses 128-bit addresses because 32-bit addresses aren't sufficient for the numbers of nodes on the modern networks. IPv6 addresses are usually written as a hexadecimal number separated by colons, such as, for example, FA80 000 4 times 0 here. Actually, let me increase the size it here 000, and so this is an example IPv6 address. Long strings of 4 times 0, as you can see here, we've written like that. Long strings of 000 numbers are collapsed into 2 colons. For example, if you want to write this IP version 6 number easily, you can also write like that. For example, 1, 2, 3. So 1, 2, 3 here. Ethernet also contains source and destination address. Source and destination address. Ethernet uses a 64-bit value called a media access control address, which is typically set during a manufacture of the Ethernet adapter. And you will usually see MAC addresses written as a series of hexadecimal numbers separated by dashes or colons. For example, MAC address writes like this. For example, 0A with dashes. We will separate here 28, 99, 3, A5. So this is an example media access control address. And the Ethernet payload, including the header and footer, is commonly referred as frame. Data transmission. Let's briefly look at how data is transferred from one node to another using the IPS data encapsulation model. In this diagram, you are seeing the simple Ethernet network with the 3 nodes, 1, 2, 3. So here, in this example, the node at here, actually let's name this the Typhoon's computer, and here let's actually make this oxley.com, and called, for example, Typhoon's network, right? In our laptop here. So for example, with the IP address 192.168.0.101 named Typhoon's computer wants to send the data using the IP protocol to the node with the IP address here oxley.com, the IP address 192.168.0.108. And the switch device, this is the switch device of us, forwards Ethernet frames between all nodes on the network. The switch doesn't need an IP address because it operates only at the link layer. Actually, remember what link layer is this? This is the layer 1. So the switch device doesn't need an IP address because it operates only at the link layer. And here I will write that down. What takes place to send the data between 2 nodes. The first step, the operating system. Actually, let me copy this here. Yeah. And make it upper. The first step, step 1. The operating system network stack. So the operating system network stack node encapsulates the application and transport layer data and builds an IP packet with a source address of 192.168.0.101. Because remember, this is the Typhoon's computer IP address. And the destination address, here I wrote that as a 2, the destination address of 192.168.0.108. And the step 2 after that, step 2 is the operating system can, at this point, encapsulate the IP data as an Ethernet frame. Encapsulate IP data as an Ethernet frame. So the operating system can, at this point, as I said, encapsulate IP data as an Ethernet frame, but it might not know the MAC address of the target node, and it can request the MAC address for a particular IP address using the Address Resolution Protocol ARP, which sends a request to all nodes on the network to find that the MAC address for the destination IP address. And the step 3 is is once the node at Typhoon's computer receives an address resolution protocol response, it can build the frame, right? As here. So the setting source address to the local MAC address of here 115577FFA1BB and the destination address. So destination address is actually this, and here our address resolution protocol just figured out our Typhoon's computer MAC address and tells us that our source MAC address is Typhoon's computer MAC address and the destination is this. And the step 4 is actually ARP response. Step 3 was ARP response, and the step 4 is lastly the switch forwards the frame to the destination node, which unpacks the IP packet and verifies that the destination IP address matches. Then the IP payload is extracted and passes up to the stack to be received by the waiting application. Network routing. Ethernet requires that all nodes to be directly connected to the same local network. This requirement is a major limitation for a truly global network because it's not practical to physically connect every node to every other node, rather than require that all nodes to be directly connected. The source and destination addresses allow the data to be routed over different networks until the data reaches to the desired destination node, as shown here. In this diagram, we are seeing two Ethernet networks, each with separate IP address ranges. Here, in this lecture, I will explain how the IP uses this model to send the data from the node at one network number 1 to network number 2. The operating system network stack node here encapsulates the application and transport layer data, and it builds an IP packet with a source address of 192.168.0.101 and the destination address of 20.0.1.45. Then, as a step 2, the network stack needs to send an Ethernet frame. But because the destination IP address does not exist on any Ethernet network that the node is connected to, the network stack consults an operating system routing table. In this example, the routing table contains an entry for the IP address 20.0.1.50 or 45. The entry indicates that the router on the IP address 192.168.0.101 knows how to get that destination address. And then the operating system uses ARP address resolution protocol to look up the router's MAC address at this 192.168.0.101. And the original IP packet is encapsulated within the Ethernet frame with the MAC address. The router receives the Ethernet frame and unpacks the IP packet. When the router checks the destination IP address, it determines that the IP packet is not designed for the router or destined for the router, but for a different node on another connected network. The router looks up the MAC address of this IP address 20.0.1.45, encapsulates the original IP packet into new Ethernet frame, and sends it onto network number 2. The destination node receives the Ethernet frame, unpacks the IP packet, and processes its contents. And this routing process might be repeated multiple times. For example, if the router was not directly connected to the network containing the node of 20.0.1.45, it will consult its own routing table and determine the next router it could send the IP packet to. Clearly, it would be impractical for every node on the network to know how to get to every other node on the internet. If there is no explicit routing entry for a destination, the operating system provides a default routing table entry, and this is called the default gateway, which contains the IP address of a router that can forward IP packets to their destinations.
To attack network protocols, you need to understand the basics of computer networking. The more you understand how common networks are built and functions, the easier it will be to apply that knowledge to capturing, analyzing, and exploiting new protocols. Throughout this course, I will introduce basic network concepts you will encounter every day when you are analyzing network protocols. I will also lay the groundwork for a way to think about network protocols, make it easier to find previously unknown security issues during your analysis. Network architecture and protocols. And let me write here something. Actually, this is the network, and we have, for example, workstation. Actually, it does computer. So this is the workstation, for example, and here so let's add one laptop again here, for example, and oops, and workstation here. And for example, let's add server again. This is the server, and let's add another server here. So these are the networks. So we will introduce more deeply about them. So this figure shows actually 5 nodes connected with a common network. So each node might have a different operating system or hardware, but as long as each node follows a set of rules or network protocol, actually, oops, let's write down here. Okay, network protocol here. So, but as long as each node follows a set of rules or network protocol, it can communicate with the other nodes on the network. To communicate correctly, all nodes on network must understand the same network protocol. A network protocol serves many functions, including one or more. For example, let's write it down here. Text here. So, oops. So network protocol functions here. Network protocol functions. So what network, as I already told you, that network protocol serves many functions, including for example, maintaining session state. So what maintain session state means, these protocols typically implement mechanisms to create new connections and terminate existing connections. Create new connections and terminate. Actually, can I do like that? Yes. And terminate existing connections here. So these are the functions of network protocols, and this also identify nodes through the addressing. Oops. By nodes. So what identifying nodes through the addressing means? Okay. So data must be actually this addressing. So data must be addressed. So and transmitted to correct node on a network. So some protocols implement an addressing mechanism to identify specific nodes or groups. Actually, some protocols. Actually, not some protocols implement an addressing mechanism. To identify specific nodes or groups of nodes or groups of nodes. And here this network protocol serves many functions. As you know, one of them is controlling flow. Controlling flow. So the amount of data transferred across a network is limited. Protocols can implement ways of managing data flow to increase throughput and reduce latency. And we have also guaranteeing the order of transmitted data. The order of transmitted data. So many networks do not guarantee that the order in which the data is sent will match the order in which it's received. A protocol can reorder the data to ensure it's delivered in the correct order. And we also have detecting and correcting errors. So many networks are not 100% reliable. Data can be corrupted. It's important to detect corruption and ideally correct it. And we also have lastly formatting and encoding data. So data isn't always in a format suitable for transmitting on a network. So a protocol can specify ways of encoding data, such as encoding English text into binary files. So we have also Internet Protocol suites here. Let's come here. So the TCP/IP is the de facto protocol that modern networks use. TCP/IP. So these protocol, actually, although you can think of TCP/IP as a single protocol, it's actually a combination of two protocols. So what TCP/IP means here, text here, TCP/IP is combination is TCP/IP is a combination of two protocols. These are the actual. Can you see my screen? Yes. These are the transmission control protocol plus internet protocol. These two protocols form part of the Internet Protocol Suite, IPS. So a conceptual model of how network protocols send network traffic over the internet that breaks down network communication into 4 layers, as shown in this illustration. So as you can see, Internet Protocol Suite, application layer, transport layer, internet layer, link layer, and these are what these layers use, what protocols these layers use, and this is the link layer, is the physical layer. So these are the 4 layers from a protocol stack. So this link layer, actually link layer, this is the layer 1, layer 2, layer 3, and layer 4. Let's start with link layer, layer 1. So this layer is the lowest level, and this describes the physical mechanisms used to transfer information between nodes on a local network. Well-known examples include Ethernet. Here, can I show you? So this is the Ethernet port, for example, or point-to-point protocol. So these are the physical layer, and top of them, this is the layer number 2. So this is the internet layer. So this layer provides the mechanisms for addressing network nodes. Unlike in layer 1, the nodes don't have to be located on the local network. This level contains the IPv4, IPv6 on modern networks. The actual protocol used called either IP version 4 or IP version 6. And then let's talk about our third layer, transport layer. This layer is responsible for connection between clients and servers, so sometimes ensuring the correct order of packages and providing service multiplexing. Service multiplexing allows a single node to support multiple different services by assigning a different number for each service. So this number is called a port. TCP, the user datagram protocol, operate on this layer. TCP and UDP operate in this transport layer. And lastly, we have application layer here. So this layer contains network protocols such as hypertext transfer protocol, HTTP, which transfers web page contents. We have the simple mail transfer protocol, for which transferring email, and domain name system protocol, which converts a name to a node on the network. Throughout this course, we will focus primarily on this layer, actually, but we will focus on all of these layers, so this is the most important layer for us. Each layer interacts only with the layer above and below, but there is a must be external interaction within the stack. So like that. One here. And here. So now let's create a new figure to for better understanding. here. This is the one box here, and this is the mail application. This will be our mail application here. Mail application. This is the mail application, and this is the human here. Let's just an user here, for example. This will be our user. So let's add some box here as well. So this will be a user interface, which is HTML rendering, and we will content parsers here, content parsers like text, HTML, GPG, content parsers. What this will is text, for example, HTML, GPG, and we'll top of below them is we will have network communication, so what this will is SMTP, for example, POP3 and EMAP. So this is the email application. So SMTP, POP3 and EMAP is the mail protocols, and this will be network here, and server here, server. This network will go to directly this server, and user interface will directly go to our human. So typically applications contains these components. First is network communication. So this component communicates over the network and processes incoming and outgoing data. For a mail application, the network communication is most likely a standard protocol such as SMTP, POP3 and EMAP. And we have here content parsers as well. So data transferred over a network usually contains content that must be extracted and processed. Content might include textual data such as the body of an email, or it might contain pictures or videos. And we have user interface for user. So the user interface allows the user to view received emails and to create new emails for transmission. In a mail application, the user interface might display emails using HTML or PHP in a web browser. Note that the user interacting with the user interface doesn't have to be a human being. It could be another application that automates the sending and receiving of emails through a command line tool. And we have here data encapsulation, which we will discuss this in next lecture. Data encapsulation. Each layer in the IPS is built on the one below. And each layer is able to encapsulate the data from the layer above, so it can move between the layers here. So data transmitted by each layer is called protocol data unit. As you can see here in this here, bidirectional, directional, and not directional. So we have headers, footers and addresses. So the PDU, protocol data unit, in each layer contains the payload data that is being transmitted. So its common prefix, header, which contains, as you can see here, Ethernet header, IP header, TCP header here. And for the payload, this header contains information required for the payload data to be transmitted, such as the addresses of the source and destination nodes on the network. Here, source address, destination address, source address, destination address, source port, destination port. So actually, sometimes a PDU also has a footer that is suffixed to the payload data and contains values needed to ensure correct transmission, such as error checking information. So this figure here, as you can see here, shows the PDUs are laid out in the IPS. So as you can see here, the TCP header contains a source and destination port number here. Source port, destination port, as you can see here, source port and destination port. So these ports allow a single node that have multiple unique network connections. So port numbers in TCP here, let me mention here. So this means tip here, port numbers. Here actually port numbers in TCP, port numbers actually port numbers in TCP or UDP starts from 0 to 65,535 here. So most port numbers are assigned as needed and to a new connections, but some numbers have been given special assignments. So for example, port number 80 is for HTTP protocol, and 21 for FTP protocol, and more. So you can find a current list assigned port numbers in the ATC services file on most Unix-like operating system. So a TCP payload and header are commonly called a segment, whereas a UDP payload and header are commonly called datagram. So the IP protocol uses a source and destination address here, as you can see here, IP port, source address and destination address. So the destination address allows the data to be sent to a specific node on the network. So the source address allows the receiver of the data to know which node sent the data and allows the receiver to reply to the sender. So IPv4 uses 32-bit addresses. Here, let's mention this also here. Actually, yes, IP version 4. Oops. IP version 4 uses 64, actually not 64, 32-bit addresses. Which you will typically see written the number separated by DOST. For example, here 1132, 168, 0.1. So these are the 32-bit addresses. So and separated by dots, as you can see here. But for example, but IPv4 here, it's good to mention the tips here. It's useful. IP version 6, IP version 6 uses actually 128-bit addresses. 128-bit addresses. So because 32-bit addresses aren't sufficient for the number of nodes on a modern network. So for example here, for example, FE80 000 for example, and like that. So IPv6 addresses are usually written as hexadecimal numbers separated by dots, such as this. Separated by colons, actually not dots. As you can see here, IPv6 is separated by colons, but IPv4 is separated by dots. So this here writes with hexadecimal numbers, for example, AB 891.2 here, like that. So long strings of 4 times 0 numbers are collapsed into 2 columns. For example, this here, this 40 can written like just that, so this is the same as previously. So Ethernet also contains source and destination addresses. For example, here, source and destination addresses in Ethernet here, source and destination addresses. So this Ethernet uses 64-bit value called media access control. Here, Ethernet uses 64-bit. Actually, it's 64-bit, right? Yes, it's 64-bit MAC addresses, which called addresses called MAC. What does MAC mean? This MAC mean is media access control. Media access control. So, which is typically set during manufacture of the Ethernet adapter. You will usually see MAC addresses written as a series of hexadecimal numbers. For example, actually, like that here, 0A. For example, 00, 27, 90, AB, or F0, like that. So the Ethernet payload including the header and footer is commonly referred as frame. Here, as you can see here. Here, as you can see here, we write it and I created an illustration here. Data transmission. Let's briefly look at how data is transferred from one node to another using the IPS data encapsulation. So now I want to create another illustration live here for better understanding. So let's computer here. Actually, it's okay. Personal computer here. This is our first personal computer. We have the switch here. Actually, switch here, and actually not switch. Let's make it more realistic. Okay, let's put it here. Rather, consider this as a switch. And let's add here another computer. Actually, let's copy it. Okay. Here. And let's add actually let's add another. For example, let's add laptop here. Here. And this is our laptop. So let's give an IP address and a MAC address to these machines here. So for example, let's make it here. Oops. This is let's make it 192 point 192.168 point for example 1.100 here, make it with a bold here, and let's make this here not 100 because they are the same network. We will make it 101 here, and let's give an MAC address to it here. Oops. MAC address, MAC here. MAC address will be 110022A2, for example, B3 and 55, and this is the IP version for address here. This is MAC, this is an IP version for address, and let's assign it. So we will not assign this MAC address yet, and let's add another here, IP version 4, make it a little higher here, and change this to for example 50 here, 50, and let's give MAC address to it, just different MAC address here, because MAC addresses are unique, but you can change MAC addresses not only your hardware but software way. So for example 667788 AB CD 33 here, for example. This is the MAC address and this is the IPv4 address of our computers. So what this will here, so now we will create actually connections on it here. Oops, let's copy and drag here. So actually let's connect this to this, and make it a little lower. Connect this computer to this and this to this. So in this example, the node here, this is the node here, with the IP address 192.186.1.101 wants to send data using the IP protocol to the node at this computer. With the IP address 192.186.1.50. So the switch device, this forwards Ethernet frames between all nodes on the network. So the switch doesn't need an IP address because it operates only at the link layer. In this case, actually, this is not a switch really. Switch is switch here. Switch is this. It's not router. It's router switch. This is the switch. Here. So here's what takes place to send data between the two nodes. So the operating system network at stack mode here encapsulates the application and transports layer data and builds an IP packet with the source address of 100, actually 100 source address of 192.168.1.101 and the destination address of 192.168.1.50. So the operating system can at this point encapsulate the IP data as an Ethernet frame. So, but it might not know the MAC address of the target node, so it can request a MAC address for a particular IP address using the Address Resolution Protocol, ERP. Here, let's mention it here. ARP is Address Resolution Protocol here. So, which sends a request to all nodes on the network to find MAC address for the destination IP address. And then once the node at this receives are actually not this once the node this computer receives our ARP response, it can build the frame. So this will set the source address to the local MAC address of this 11.0022A2B3 and 50 So this will this source address. So this will assign it to the destination address. So 6677888ABCD33. And the new frame is transmitted on the network and is received by switch. And finally, the switch forwards the frame to the destination node, which unpacks the IP packet and verifies that the destination IP address matches. So then the IP payload data is extracted and passes up the stack to be received by the waiting application. In this lecture, you will learn the network routing here. Let me make sure that increase the size a little bit. Just not. Okay, so Ethernet requires that all nodes to be directly connected to the same local network. This requirement is a major limitation for a truly global network because it's not practical to physically connect every node to every other node. So rather than require that all nodes to be directly connected, the source and destination addresses allow data to be routed over different networks until the data reaches the desired destination node, as shown in this figure here. So in this figure I created one. This shows the Ethernet networks, each with separate IP network address ranges. So as you can see here, the operating system network stack node here encapsulates the application and transport layer data, and it builds an IP packet with the source address of 192.1.1.1.101. And the destination address here, as you can see here, 100, actually not 100, this is the 200 because this is the absolutely different range, 200.150. So then the network stack needs to send an Ethernet frame, but because the destination IP address doesn't exist on any Ethernet network that the node is connected to, the network stack consults its operating system routing table actually. So it will look routing table. So in this example, the routing table contains an entry for IP address 200.0.1.50. So the entry indicates to the router on IP address 192.1.1.1 to this knows how to get to that destination address. So actually, in this case, in our case, this router here, knows where to go with that address. And then so this stage is completed and the new stage comes. This is the third stage. So then the operating system uses ARP, as in previous lecture we write something here. What ARP means? ARP is Address Resolution Protocol. Actually, This is the ARP is address resolution protocol. So then the operating system uses address resolution protocol to look up to the router's MAC address at 192.1.1.1, and the original IP packet is encapsulated within the Ethernet frame with that MAC address here. So, and then router receives the Ethernet frame and unpacks the IP packet. Here, when the router checks the destination IP address, it determines that the IP packet is not destined for the router, but for a different node on another connected network. In this case, the router looks up the MAC address of this device, 200.0.1.50, and encapsulates the original IP packet into the new Ethernet frame and sends it onto the network 2. This is the network 2 and this is the network 1. Network 1 here and network 2 here. So, and lastly, the destination node receives the Ethernet frame and unpacks the IP packet and processes its contents. So the routing process might be repeated multiple times. For example, if the router was not directly connected to the network containing the node of 200.0.1.50, it will consult its own routing table and determine the next router it could send the IP packet to. So clearly, it will be impractical for every node on the network to know how to get every other node on the internet. If there is no explicit routing entry for the destination, the operating system provides a default routing table entry called the default gateway, which contains the IP address of a router that can forward IP packets to their destination.
The network is the first thing we think about when we imagine computers getting hacked, right? And it's the pentester's playground. It's both the first step and the final frontier of compromising a computer. It's also what makes the compromise of a single computer effectively and the compromise of an entire building full of computers. It's fitting. Then we continue our journey with a discussion about compromising the network and using its own power and weaknesses to inform the pentest. The first step is getting on the network, and there are human, architectural, and protocol factors that make the mere presence of an attacker on the network potentially devastating. For this reason, defenders often deploy network access control (NAC) systems. The intent of these systems is to detect and prevent an intrusion on the network by identifying and authenticating devices on the network. In this section, we will review some of the methods employed by the NACs and demonstrate practical methods of bypassing these controls. Now, let's get started by the learning of bypassing media access control filtering and things to consider for the physical accessor. An attacker needs to be aware of the methods for the remote compromise, attacking the VPN, wireless infiltration from a distance using a high-gain antennas, and so on. However, pentester can never forget the big picture. This is a field where it is very easy to get caught up and in the highly specific technical details and the misty human element of security design. There is a design flow concept that pentesters like to call the candy bar model. This simply refers to a network that is soft and crunchy on the outside but gooey on the inside. In other words, it's a model that emphasizes the threats of the outside world when designing the security architecture, while assuming that someone who is physically inside the company facilities had been vetted and therefore trusted. The mindset here dates back many years. In the earlier days of what became the internet, the physical access points to the network were inside highly secure facilities. Packets coming in over the network were safely assumed to be from a secure environment and sent by an authorized individual. In today's world, A packet hitting the border of a company's network could be from an authorized individual on a business trip, or it could be a very clever teenager on the other side of the planet, eager to try out some newly learned tricks. The candy bar model will come up in a later lectures when we discuss other network attacks. Once you crack the outer shell, you will often find that the path forward seems paved especially for you, and the successful compromise will inform your client of the devastating consequences of this mistaken assumption. Feel free to treat yourself to an actual candy bar upon successful compromise. You deserve it. How to social engineer your target is a subject for another section altogether, but for the purposes of this discussion, let's assume that you have a physical access to network drops. Not all the physical access is the same though, but if you convinced your target to hire you as a full-time employee, then you will have constant physical access, right? They will even hand you a computer. However, what's more likely is that you have exploited a small gap in their physical security stance, and your presence can be undetected or tolerated for only a short period of time. You have snuck in through the smoker's door after striking up some conversation with an unwitting employee, or you've been given permission to walk around for an hour with a convincing looking contractor uniform and clipboard. Or, which is my personal favorite, you earned trust and affection by bringing in a big box of donuts for the people expecting an auditor's visit based on a well-scripted phone call. And my client's still shaking after this test and will ask whether the donuts were real. And for now, we will demonstrate how to set up a Kali box to function as a rogue wireless access point while impersonating the media access control address of a voice over internet protocol phone. So you have found an unoccupied cubicle with an empty desk and a generic IP phone. So the phone is plugged in and working, so you know the network drop is active, and we will drop our small laptop running Kali here and continue the attack from the outside. So first we unplug the IP phone so that our bad guy can take the port, and we are then going to clone the MAC address of the IP phone on our Kali box Ethernet port. From the perspective of simple MAC address whitelisting methodology of NAC, this will look like the phone merely rebooted. So here I use ifconfig to bring up the interface configuration, but first let's actually increase the font size a little bit so you can see better. Here, now actually let's make here, and I also want to add the margins here, which is, I think, has to be somewhere here. If it's not, it's also okay. I think you can see clearly here. Yes. Terminal, yes. And here, this is our terminal margin, and we can make it like 50 pixel, and here. So now let's use the ifconfig here, ifconfig, and here you are seeing Gromit. Actually, let me open my Gromit here, here, and this is our marker which we're gonna use. And here, as you can see here, that in my example, my Ethernet port interface is called ETH0, and my wireless interface, which I don't have wireless interface right now, but if you have, it's gonna be called the WLAN here. Let me write it, WLAN 0, the first wireless card. And I will note this for later, as I will need to configure the system to run access point with a dynamic host configuration protocol, DHCP, and the domain name system, which is DNS. And here on actual WLAN, which I will add my card later. And while running the network address translation through my Ethernet 0 interface. And I can use if config here. Let's actually do this. So I can use the if config the ETH0, which is my Ethernet card, HW Ether. So here I use this to change the physical address of the Ethernet interface. So I sneaked a peek at the label on the back of the IP phone, and the MAC address is here. See here, the MAC address is, as you can see here, lob slib sh ppp arcnet sit and so on. So actually this here if config ETH0 and Ether. And as you can see here, we got several informations here. This is hardware type, list of possible hardware types. Here we have usages of how this works and so on. And let's now run the ifconfig command. And as you can see here, we have the Ethernet MAC address. So now let's bring the interface with this. So we're gonna use so we have to be the sudo, the super user of the system, to use this command. Now let's use the sudo s and enter your password. And here, as you can see here, we, instead of using Oxal account, which is a separate account, and this is our computer name, we came into the root account, which we are working on a directory of home Kali, but you actually learned this in lectures. So if config ETH0, and here we are seeing our Ethernet MAC address, like eNet address, this is a local net mask, broadcast, and so on. Now after that, we will use if config ETH0 down. And here I will explain all of this later, but first let's write this config ETH0 w ether, and let's change our, as you can see here, our disconnected, we had the label disconnected from the internet, see here, but we will enable it. But now firstly HW ether, and we will enter our MAC address that we want to use, which in this case, like something like AACCBB or something like 989221 and lastly 1A. And here after that we will enable our Ethernet 0 interface. So if config ETH0 and up. As you can see here, our internet came live here. So now we will use if config ETH0, and as you can see here, our MAC address is changed. The goal of passive and active reconnaissance is to identify an exploitable target. And the goal of vulnerability assessment is to find the security flaws that are most likely to support the tester's or attacker's objective. For example, unauthorized access, denial of services, or modification of data. The vulnerabilities assessment during the exploit phase of the kill chain focuses on creating the access to achieve the objective mapping of the vulnerabilities to line up the exploits and maintain persistent access to the target. Thousands of exploitable vulnerabilities have been identified, and most are associated with at least one proof of concept code file or technique to allow the system to be compromised. Nevertheless, the underlying principle that governs success are the same across networks, operating systems, and applications. In this course, you will learn using online and local vulnerability resources. You will also learn writing your own Nmap script using the Nmap scripting engine, web and application specific scanners. You will also learn threat modeling in general. You will learn how to select and customize multiple vulnerability scanners. Vulnerability scanning employs automating processes and applications to identify vulnerabilities in a network, system, operating system, or application that may be exploitable. When performed correctly, a vulnerability can deliver an inventory of devices, known vulnerabilities that have been actively scanned for, and usually a confirmation of how compliant the devices are with various policies and regulations. Unfortunately, vulnerability scans are loud. They deliver multiple packets that are easily detected by most network controls and make stealth almost impossible to achieve. They also suffer from, for the most important part, vulnerability scanners are signature based, so they can only detect known vulnerabilities, and only if there is an existing recognition signature that the scanner can apply to the target. To a penetration tester, the most effective scanners are open source, so they allow the tester to rapidly modify code to detect new vulnerabilities. And also, scanners produce large volumes of output, frequently containing false positive results that can lead a tester astray. In particular, networks with different operating systems can produce false positives with a rate as high as 70%. And scanners may have a negative impact on the network. They can create a network latency or cause the failure of some devices. So it's recommended to tweak the scan by removing denial of service type plugins during initial scans. And in certain jurisdictions, scanning is considered hacking and may constitute an illegal act. And there are multiple commercial and open source products that perform vulnerability scans. Wireshark is a protocol analyzer that can capture traffic and then present it in a human-readable format. In this section, you will gain an insight into overall functionality of Wireshark, and we will see how to troubleshoot network traffic, monitor for security issues, and debug applications. We will also cover how you can and where you can find a list of shortcuts so you can confidently and quickly capture and analyze packets. So that you can better appreciate the work that goes into Wireshark, we will also review a list of many authors that contribute to this project and help make Wireshark an exceptional tool. We will also see where you can find links on the interface that provide helpful information on how to better use Wireshark. In order to better understand the packet analysis process, we will briefly review each of the phases involved. These are gather, decode, display, and analyze. We will then review the built-in command line interface tools that complement a Wireshark's basic functionality. We will then finish with a closer look at T-Shark, a lightweight command line interface application which you can use when you need to capture traffic without the resource-intensive overhead of using Wireshark. In this section, you will learn about examining the Wireshark interface, understanding the phases of packet analysis, and learning how to use the Wireshark command line interface tools. Wireshark offers a comprehensive framework for analyzing network traffic, and it performs well on most operating systems. And the interface is streamlined with shortcuts and methods to make navigation easier and get you up and running with analyzing traffic. And in this lecture, we will discover how Wireshark presents information along with where to find a list of keyboard shortcuts. And we will also take a look at the many authors who have made this application possible and describe some ways you can obtain help and learn about Wireshark. So let's start with a brief look at Wireshark interface. So let's first start Wireshark. You can also start Wireshark from terminal without just typing Wireshark, and you can also start with the sudo credentials, but in this case we will just start with a normal Wireshark without sudo or anything for now. And in some cases, you will need to start Wireshark with sudo privileges. And now, when you first launch Wireshark, you will see a list of active interfaces. And some have a sparkline or moving graph symbol next to the interface here. And when present, the sparkline represents actively changing data, and you can select that interface and begin capturing. And here, as you can see, our arrow is down, our analysis is down here. So whenever we enter some website, here let's actually enter Polyforms, and here, as you can see, it's spiked up. So as shown here, this is our both Ethernet, also select any. In this case, we don't have connected Bluetooth or any wireless devices. So now, during analysis, Wireshark has many ways to improve your experience. So first, let's actually select firstly Ethernet, and then we will start here. As you can see, it's empty. So whenever we go here, let's actually go to NetHunter, and as you can see, it actually it works actually very fast and real-time data on your screen here. So it might look like pretty disarranged, but it's actually it arranged in some way, which I will explain all of these in this section. So now, for example, when working with a package capture with Wireshark, we can easily add columns to the interface. So simply right click on a value with the packet details here. And now you can also apply as filter, prepare as filter, mark unmarked, protocol preferences, decode, show packet new info. Here, as you can see, here, there's a we can also edit, resize contents and resize column width, and here apply as filter. So now we will select something here, and see here we can also select a number, that column, and so on. We can also change the title of it, so number, and so on. So Wireshark also includes intelligent scroll bar, which is on the right side of the packet list here. So you can also go to view, and here we can expand all, view, reset layout, colorize conversations, resize column, reset layout. We resetted our layout, kernel, show packet in a new window, and as you can see here, the new window just popped out, and we can see more information now. And here we can also type our display filters, which you will learn all of this course. And now we will start with how to discover keyboard shortcuts in Wireshark. So with millions of downloads per year, Wireshark has become a significant tool. It has proven to be flexible as an open source utility and encourages developers to add functionality as well as improve overall experience. So each new version improves the application, and improvements can include fixing a simple visual or display or more significant problems that can cause an application to crash, such as alpha dissectors. So when you update Wireshark, take time to read the notes, which will see. You can also see here. Just Google it. Wireshark update notes, and here there's also you can also see the what's new, bug fixes, new and updated features like new protocol support, updated protocol support, new and updated capture file support, and you can also get help from that. So first, let's actually solve this captcha, and we will begin by explaining. It's not working, so we can read. Oh no, it's done. As you can see, there's a release notes on Wireshark's official web page. As you can see, the last version of this 4.0.5, and here what's new. In what's new section, you can see bug fixes, file locations, getting Wireshark, and so on. So let's get started fastly with let's get started with discovering the keyboard shortcuts, right? So everyone has a preferences as how they interact with Wiresharks. Some individuals prefer using a keyboard as it's faster and more intuitive than using a mouse like that. So Wireshark has a list of keyboard shortcuts that can be found by selecting from this help menu choice, then clicking about Wireshark, and then selecting keyboard shortcuts here. You can see in the tab here. So now we are seeing every shortcut, every possible shortcut in Wireshark. So for example, when working with a package capture, many times I will select, as you can see, Control++, which will zoom in on the main text of the interface. Let's try that actually. Click OK, let's zoom in that here. You can see here, and zoom in, zoom out like that, zoom in. Please zoom in now. Here. Here. We can barely see it. That's because I will zoom again. Yes. Actually, check that. Shortcuts again. And here, zoom in, zoom out, zoom in and zoom out here. So now we will use that zoom in. Unfortunately, let's actually close that Wireshark and open the Wireshark again. We have some shortcut problem here. Internet 0, and here let's go to some website, and here we are doing that again. I guess my plus key on my keyboard is broken, so we will use that. You can also change that here. Oops, not here. You should change this from the file and no, edit preferences, and here you can change that font and columns, layout, capture, expert, filter buttons, name, resolutions. You can also change the protocols. You can give them individual colors to know exactly what protocol is it or not, and you can see the statics, advanced, and so on. So yes, I use my laptop's keyboard to here. You can see here we can zoom in and zoom out, and now all of these improvements over the years have been possible because of the generosity of the open source community. And here you can see keyboard shortcuts plugins that these are the default plugins because of this lecture. I didn't install any plugins for you. If we will need any plugins, we will install on this lecture. So let's firstly recognize our authors, right? Who developed this awesome application. So these are the many authors have contributed to the success of the Wireshark by providing ongoing development and maintenance of the application. So some consistently jump in to add their expertise, and others contribute only when they need a specific protocol sector. So anyone can be involved, as there is plenty of documentation on how to add a basic dissector. If you do modify Wireshark to add a dissector or visual enhancement, share your work with the Wireshark team so that everyone can benefit. So now let's find information here across the bottom of the right hand side of the Wireshark. So welcome interface, you will see learn label. So firstly, of course, we need to first quit, and let's go to Wireshark's welcome screen, right? And here we have profile, Bluetooth classic. Here, let's go select classic. Let's actually click default for you here. Now we're gonna understand the phases of packet analysis. Packet analysis is the process of gathering traffic on the network, decoding it and dissecting the raw bits, and presenting it in humor-readable format for analysis, as shown here. gathering, decoding, displaying, and analyzing. So regardless of the software used, there are four main phases of the packet analysis, as I said in previous lectures, which is gather, decode, display, and analyze. In this section, we will review each of the phases, starting with the first step, which is gather, where we collect data from the network. So now let's go back to our Kali Linux. It's actually, Wireshark is independent from the operating system. You can use Windows or Mac OS or operating system you want that Wireshark supports it. So now let's go to Kali here and here. Yes, perfect. Now open the Kali here. Yeah. So let's launch Wireshark. So when you launch Wireshark, a welcome screen displays a list of available network connections on your current device. And this is in most cases, you will have more than one interface. And to begin capturing immediately, you can select an active Spark line and begin capture. Apparently, now let's go to, and you can also go to capture menu if you want. Then go to options here. So capture options. So as you can see, there's also shortcut. You can also click on the shortcut here. This will same screen will open here. So now there's keep in mind that there are two keys areas that will enable you to gather traffic, which is capturing in promiscuous mode and using a capture engine. So let's first discuss why it's important to enable promiscuous mode prior to capture. So the capturing in promiscuous mode. So, when gathering traffic with Wireshark, you can capture on all interfaces, however, so that you can see all the traffic that is coming into the network interface card. Make sure you select one of the following when on the input tab of the capture options dialog. So check the box next to the interface under the promiscuous column header. So as you can see, enable promiscuous mode on all interface. So here, and secondly is you have to enable the promiscuous mode on all interfaces as you can see here, right? So you can also we have update output options, and we have here address of our Ethernet network, manage interfaces, and so on. So as you can see here, we can also as I said, firstly, you should make sure that this promiscuous is checked. So after choosing an interface to listen on and placing it in promiscuous mode, the interface gathers up the new traffic. Like double click on your interface, and here, as you can see here, my interface is gathering new traffic. So if I go to some website like oxley.com, it will here send us a bunch of requests and signals, right? So here, this is our website also. So part of the effect of the capturing traffic is having an appropriate package capture PCAP engine installed, and the PCAP engine provides an application programming interface API that capture traffic from the network so that it can be processed by operating system. In this case, we will not install that for now. And first, let's learn about how to decode bits in Wireshark, which you will learn in next lecture. Traffic enters a network interface card in a binary form, one frame at a time. So there's here, as you can see here, we have source IP, source port, and here Ethernet 2, source address, and so on. Type IP version 4, Internet Protocol version 4, flags, time to live 1, protocol UDP, and so there's so much information that we will need to analyze, right? So while the space, the Wireshark uses the Enhanced Packet Analyzer (EPAN), which decodes the bits into human-readable format. So let me take my Gromit to draw things on the screen, and here apply. So this is our bits. So these are the hex codes and so on. So obviously you can't read this in your bare eyes, and there's some information about that. And here, after getting this raw information, Wireshark translates it to with Enhanced Packet Analyzer Engine, which decodes, as I said, decodes the bits into human readable format here. Perfect. So now we will step through the EPAN. So prior to 2006, Wireshark was called Eternal. So yeah, so the name has changed, however, as obviously the main core is the same, right? So EPAN is the packet analyzing engine for Wireshark that used the sectors, also known as decoder. The sectors provide information on how to create the protocols in the proper format according to appropriate request for Commons RFC or other specification. So EPAN contains 4 main APIs, which is the first is protocol tree, the sectors, sorry for this, the sectors, the sector plugins, and display filters. So we have the protocol tree, which is this displays the detailed analysis of a single packet. We also have the sectors. So these provide information how to break down the protocols into proper format. We also have the sector plugins. So these use the sectors as a separate functions. And lastly, we have display filter, and this allows you to filter captured data. In most cases, Wireshark is able to correctly identify and dissect the protocol. However, there are times when you will need help. Wireshark decode the protocols, right? So you can achieve this by right-clicking on the frame here, and here you will go to decode as here, which will bring up this dialog. Here, as you can see here, we have several options here. So once in this window, you can modify the values to match the appropriate protocol. And this function is very useful when protocols either don't have a dedicated port or they are running on a different port compared to the usual. For example, you should use decode as when HTTP is running on port 8080 instead of port 80. So once the bits have been converted into proper format, the next step is to display the results in human readable format. So now let's display the result here. So in Wireshark, along with the many other packet analysis tools, there are many options to enhance your graphical experience. So when you open a packet capture in a Wireshark, the default layout for the main display is in the 3 panels, which is here. So let me take my pen again. So this is our, can you see it? Sorry, please come. I guess we here. So toggle painting home, shift home. Yes, perfect. So here, this is our packet list. This tab we are using for is our packet list. These are the packet details here. These are the packet details. And obviously these are the raw format, which is a packet bytes. So the packet list here, this is a list of all captured packets where each line represents a single packet. As you can see here, broadcast, IP, destination source, protocol, length info, and so on. Everything has a source and destination, right? This was so philosophical here. So we also have packet details. So here, this is a packet details. This displays the details of a single packet and includes the protocols and field values. It also displays Wireshark specific hints. For example, when examining the TCP here, let's choose some TCP here, TCP. Oops, of course we have to use here. So this is our TCP. So when you examining a transmission control protocol header, you will see the stream index listed below the source and destination force, right? So however, there is a no field value called the stream index, and a stream is a communication between two endpoints that compromises the endpoint A socket and endpoint B socket. So to help to keep track of all those streams, Wireshark lists each stream in a TCP header. Here now we have a transmission control protocol. Let's actually, here you can also protocol. Here open this tab, transmission control protocol, and as you can see here, stream index 1. Let's can we here, yeah, stream index 1. So I hope you see clearly. So stream index 1. So this is what I've called endpoint A socket and endpoint B socket, which is source and destination ports. However, there is no field called stream index in some cases, and that's how you can bring it up. And we also have packet bytes. This is a hexadecimal representation of a single packet, as shown, as you can see here. And any plain text data is displayed on the right hand side, as you can see here. This link.net something something here. Yes, let's get some meaningful text here because it happens sometimes, right? Okay. You can also use your arrow keys to get those information, and okay, here, perfect. That's it. That's our request, the HTTP request. So this is a hexadecimal representation of a single packet as shown here, and any plain text data is displayed on the right side, and these are the hexadecimal. This turned to our text. And after that, if it's not enough for you, the Wireshark like analyzes it itself, and here request version, request URI, request method, post request, and so on. We can, in next lecture we will also learn how to change the layout, how to analyze the package capture, and so on. I'm waiting in next lecture.